the project.
The other day, and you press it, change right away.
Yeah. So okay, so that was one issue, that we pressed the button, you know, wouldn't change to the other sequence right away. So what was the issue there? Why wasn't it responding to your button press? Yeah.
It's in a loop, it doesn't go.
Yeah, it's in a loop. If it's doing something else, if you're waiting for half a second in a busy loop, you can't check the switch until the half second's up, so you'd have to hold it. Or even, a worse design would be like going through the entire cycle before you check the switch, which means you'd have to hold the switch for the entire cycle until. So anyone find a fix to that? Yeah.
Check the switch in the loop.
Check the switch in the loop, between the LEDs. Check it in the timing loop. So like every, so if you have to wait for half a second, you could still, in your loop, wait for 1/10 of a second 5 times, and then check for the switch every 1/10 of a second. Now that requires that you set some sort of variable to indicate that the switch has been pressed or released, so then when you come out of the loop, then you can switch to the other sequence right away. So that's one approach. I mean, right now, we're still kind of learning. A little later on, we'll see how we can write interrupt routines. With an interrupt routine, the instant you press the switch, it'll cause the microcontroller to go off and run this other code, this interrupt code that you can use to set. Again, you typically set a variable there. Right, we haven't gotten to that point yet on how to deal with interrupts. So there are issues like switch presses. The other thing is there's a tendency, I think, when things aren't working, to keep throwing more and more complex code, when the problem is you need to just back up. And this project was pretty simple, and you can probably do it in, 40 lines of code at most. But you can get going down these rabbit holes where things aren't working and start adding more and more code, and it's just poor design, instead of stepping back and saying, maybe I need to relook at this. What's probably more important than that is you have to leave yourself time to debug these projects. Maybe in any software development, 3/4 of the time is spent in debugging the project and getting it to work. And they're just simple errors that can occur, using logical AND versus bit ANDing or something like that. But it takes time to fix these problems that you run into with your software. Several people actually have multiple files in the project with multiple main routines. You can't have that. There can only be one main routine. You get a link error then about multiple definition of main. So I guess watch out for that. Anything else? Okay, we're going to talk a little bit about programming. This chapter has a brief review of, and I'm going to have you kind of do this project over again for your next project. But, and maybe some of you did this already in this project, and that's fine. You'll be ahead of the game. But in this chapter, he goes through a review of C and some of the fundamentals of for loops, while loops. I'm not going to, if statements, I'm not going to go through a lot of that, but there are some things I want to touch on. so as a section here, I talked about keywords. I want to primarily use this though to talk about, so we're programming in standard C, but things, we've got all the stuff that's predefined for us, like the ports, the names of the registers. There's some strange, if you start looking through the header files, there's some things that don't look like standard C, for example. But all of these are actually defined in various header files. So they're in different categories. So the standard C include files, like standard io.h, string.h, standard int.h, R, N, and I'm going to call it CCS root. It's wherever you installed Code Composer Studio, and then CCS tools, and then the compiler. And with the default install of Code Composer Studio, you actually get two compiler suites. You get one from TI, it's called the Code Generator Tools or something like that. And those are in TI, CGT, ARM, and then it goes on. I think there's a version number, and then include. You also get the new compiler suite for ARM as well. We haven't been using that, and I'm not planning to. We'll stick with the TI tools throughout the semester. So, but there are two ways you can find those here in Code Composer Studio. If you expand this includes, and then here's the one I was talking about. So that there are actually, it's showing 4 different include directories. Here's the one, TI, Code Composer Studio, tools, compiler, TI. You can expand that and see all of the different. You'll see standard io.h here, standard int, string.h. Those are all defined here. These are the header files that are part of the C standard language. In addition to those, well, one of the ones we have been using is, and these may be new to you, is like uint8 _t or uint32 _t or int32. Those are all defined in this standard int.h. So actually, wanted to open it. So here's that file. And unfortunately, in the C standard definition, int isn't defined to be a 32-bit integer. Most of us assume that it is on most microprocessors, but int is actually defined to be the natural word size now for whatever the microprocessor is. For most modern microprocessors, that's 32 bits, but back at one time, 16-bit processors were common, and an int was just a 16-bit. So int could actually be a different size on different processors. Okay, so could a short might be actually an 8-bit type. Most of us assume it's a 16-bit type. So that kind of leads to problems when you're dealing with microcontrollers, and you need exact word lengths, exact type sizes. So that's what these are all defined as. int8 _t is guaranteed to be an 8-bit signed integer. Okay, so from -128 to +127. And uint8 is guaranteed to be an 8-bit type. And we've got the 16-bit types and the 32-bit, both signed and unsigned. And you'll see in this header file, it actually depends on what microcontroller that you're using. On some of them, you can see that an int is actually a 16-bit type. But on others, an int is an int32. Now, these type defs are actually defining this thing on the right here. So in this case, it's defining int32t to just be like an alias for int. Okay. So on this particular microprocessor, an int is a 32-bit type. Okay. But on some of these others up here, you can see that a 16-bit type is actually an alias for an int. So on those processors, an int is actually a 16-bit type. So generally working with a lot of these registers are defined to be, usually unsigned 8-bit types, because most of these registers, these port registers we're working with, like the in and out, are actually 8-bit register locations or memory locations. So that's where all of these are defined. So you may not have seen these before. Again, this isn't, there's nothing really new here. These are just aliases using this type def for types that you've used in the past. Then there's all the stuff now that's particular to our microcontroller. MSP 432 include files. And they're in CCS root, CCS, CCS base, ARM, include. And you can access them conveniently through Code Composer Studio, but these are nothing more than text files that you can also access through the file system. Let's see, so here everything was installed on the TI directory, CCS, and then here you see that tools folder, compiler. Here's both the TI and the GCC compiler, and we actually have two different versions. We've been using the latest version of the TI compiler. So here, and then the include, and then here's where you'll see all of those .h files. But the ones particular for our microcontroller are in the CCS base, ARM, include. And normally what we've been including is this MSP.h file. Okay, let me just open that up with Notepad. But that really does nothing more than include, based on some defines, the particular header file that's appropriate for the microcontroller we're using, which is the MSP 401R. Yeah, there it is up at the top. So this does nothing more than, if that's defined, actually include this other file, which is defined in the same directory. And so all these different variations, here's the one we're using. These different header files actually just have the different addresses corresponding to the different variations of the MSP 432. So you can scroll down here. You'll find there's some convenient stuff here. You'll find, so I mentioned before that they actually provide for you some convenient definitions here. For bit 0 is 0x01, bit 1 is 0x02. So instead of using, like for switch 1, which is on the bit 1, that's on pin 1, I think, instead of using 0x02, you can just use bit 1. But you can also find in here, they have the addresses for all these things predefined for you. So we've been using port 1, for example, probably going to appear in here several times. Yeah, so it's nothing more than a define. And it's actually this DIO base, which is defined above, plus some offset. But it's an address. And actually, if you look for this DI port interruptible, you'll find it down here. And it's a struct, but it's got all of these in, out, the direction, the pull up enable, the drive strength, the selection registers. We've seen all of these. These last few we haven't used yet, but they're all defined as part of this struct. And so we access this thing as P1, and then that little arrow notation in, or P1, that arrow notation out, or direction. And it's actually then finding the address of these corresponding registers that are offset from port 1. Now, each of these, in addition to having like uint8, they also have this underscore I or underscore I0. Those are actually defined in another header file. Those are actually underscore I, or the underscore O, or the underscore IO are equivalent to the keyword volatile, which I mentioned before, but I think you probably never used this in your C programming language because you weren't programming hardware. What the volatile keyword indicates is that this particular variable, like n, may be changed outside of software control. So the compilers try to do things, they try to be really smart. So, if you have something like x equals port 1 n, and then maybe y is equal to port 1 n later on your code, the compiler, with a normal variable, thinking this as a normal variable, it might read it in once and say, hey, I've already got that stored in a register. I'll just copy it to this y location. I don't have to read it in again. Well, we're doing something different with microcontrollers, right? This n, the bits in this n register can be changed by hardware control when we press a switch or something like that. So this volatile keyword, which is embedded in all of these, means you can't make any sort of optimizations. You can't make any assumptions. This may change outside of software control. So declaring this to be volatile tells the compiler it has to go and read that location every time we access it. It can't assume that it doesn't change. So all of these are actually declared to be volatile, and it forces the compiler to not do some optimizations that it might normally do. So I want to talk a little bit about, he has a section on design, and we'll look at improving our code for accessing these switches and LEDs, and this will be the next project. That will make your life a little bit easier when we're using these launchpad switches. So in this modular design, you guys were introduced to this in your intro to programming class. It's really breaking a problem up, a programming project up into smaller pieces, writing functions or methods. Okay. So a couple things that you want to try to do is try to minimize the coupling between different modules. And he defines a module as, we have modules that are collections of functions that have a similar purpose. So we've actually looked at some modules already, the UART module, the SysTick module, the clock module, that are actually collections of functions that are related, but But one of the reasons you do this is, and you'll see this as we start writing a switch module today, is to actually hide some of the implementation details. So we can embed those into a function and define, what goes into the function, what the function returns, and that's all the user of the function ever needs to know. Doesn't have to know what's inside the function. As a matter of fact, as long as it takes the same input parameters and returns the same value, or that value has the same meaning, we don't care about the implementation details. Allowing someone to actually change the implementation, maybe improve it, but from the standpoint of whoever is using that module, we don't really care about how it's implemented. That's kind of what we're doing right now with the UART and the SysTick timer module. We're using them, but not really. Hopefully they're working okay. The author wrote them, made sure that they're bug free, and then so now we can use them without being concerned about the particular implementation details. So we have the SysTick module, which was provided by the author of the textbook, and it has, and most of his modules are set up like this. There's an init routine, same for the UART, same for the clock. So you have to call. That's one of the issues with the UART. Things aren't going to work correctly if you forget to use that initialization routine, and then try to use the printf, for example. And then this, after the initialization, there are really only two other functions in this module. The wait that waits in terms of clock cycles, and then he has another one that's a 10 millisecond wait. And then corresponding, also part of the module is there's a header file. So there's two parts to the module. There's the code for the functions. Then there's a header file that contains the prototypes. So when you want to use the module, you have to include in your file the header file, okay, which defines what each of the functions takes for input parameters and what it returns actually. Okay, and that's all you need to know to use it. You don't actually have to know anything else about the function in order to use them. So let's look at what if we wanted to have these modules for our Launchpad, switch, and LEDs. To make their use a lot easier, because you get a little tired of rewriting the same code over and over again. And yeah, you can copy and paste it from one project to another, but it would be nice to move all of this common code into a module. We get it working right, and then we can use it without ever having to worry about it again. So let's look at the switches. And I'm going to just call it the Launchpad switch.c and Launchpad switch.h. Okay, these would be the files making up this Launchpad switch. And I just put the Launchpad on it because it's only going to deal with the two switches that are on the Launchpad board. What kinds of things do we do every time we use the switch? Do what?
Define it.
We define. What do you mean by define it?
Define the switch. So the symbols, like to give it a place.
Give it a well. What do you do every time in your code when you're using the switch? What actual code do you write?
it's right the place of the switch, so we define it for the both to launch the switch.
Are you talking about with the define for the switch one? Yeah, but what types of things do we do to have to set the switch up? Same code you have in every one of your routines where you use the switch.
Delete.
Yeah, you do it in the main, or you can do it in the main. We're actually trying to avoid that. We're wanting to move it into this module. But what do you have to do to use the switch? What registers do you have to write to? You have to set up the selection registers for GPIO. You have to set up the direction register as input. We have to set up with the pull-up enable and the output. Those all have to be written the same things every time. So what we want to do is put that all into an initialization routine like he has for these other modules. And so we'll call that Launchpad switch init. What else do you do with the switches after you initialize them? Well, you read them, right? So it would be nice to have and you might choose to do this differently. But maybe a switch one read and a switch two read. That these return, 0 if it's not pressed and 1 if it's pressed or whatever. Okay, but once it's written, it's defined. Okay, and then this. Do we need anything else for the switches? Now the implementation details on the read, whether they're debounced or not, that can all be hidden inside here. For the LEDs, it's similar. Launchpad LED .c, Launchpad LED H. We would want the Launchpad LED init. Now here you might choose to just initialize the red or the green or the blue for the tricolor LED. Or you could say, well, I'm just going to initialize all 3 of them in the initialization routine. I mean, there may be, or maybe you could set this up so it takes an input parameter so that, if it's 0, it initializes the red one or something like that. But we need to do the initialization. And then we want some way to turn on the LED and turn it off, okay, without having to remember, which port pin is it connected to? Which port is it connected to? Which pin is it connected to? So you probably want something like green on, and whatever you want to call these. I'm not sure this is a good naming convention. These things, the names here tend to get a little long. It's usually not a big deal with cutting and pasting. We want one for green on, green off, and then probably a way to just toggle, change the state. Okay. And you could do that using on or off. You could read the state. That might be something else that we want to implement. Is actually we can read the output port to see what it's currently on. So you could include that as part of this as well, but maybe just a toggle. Again, you could have it add additional routines in here to return the state to let you know whether it's currently on or off. I don't know if you want those or not. Then you'd repeat this for the blue and the red. So let's actually look at how we would do this. So if you want to bring up Code Composer Studio or just type it in on an editor. Now, these are routines that I want to actually put in, use in multiple projects. So I actually want to add these to my source file. Let me see, can I put this? No, this only does open projects. Trying to figure out the best way to actually add this. I think what I'm going to do, my EE354 source directory doesn't appear as a project. I've just got a collection of files in there. Let me see if I can actually just make it a project so it will appear. What do I actually call it? Find it in the Explorer. It's here, EE354 source. It may not like this since it already exists. And just an empty project. Yeah, I'm just crossing my fingers that it didn't wipe out all the stuff that was there, and it didn't. So this is not really a project. I just wanted some way for it to actually show up here. So it puts some like startup files in there that really aren't part of this. I'm just going to delete those out. It doesn't matter. I'm never actually going to compile this project. Right? I'm just using this project as a repository for all of these modules that I'm going to use. Okay. So, I'm never actually going to compile it. But what I want to do here is create now a new C source file that we're going to call launchpad switch.c. And then I also want to create the corresponding header file. So new file. New header file in this project, and launchpad switch.h. Okay, and then in the .c file is where I'm going to put all of these modules. So the switch init actually is not going to return anything, so it's going to declare the return type to be void. It actually doesn't take any arguments either. What I'll do here is I've already got a project that initialized switches, so I'm just going to copy that code over. So here's the stuff for configuring switch 1. And so these are the things okay, this is just doing switch 1. You know, I want to do actually both switches here. So what I can do is, remember, I prefer you don't have to do this, but switch 1 is connected to, is it bit 1? So this is why you want to program this in and forget about it, so you don't have to keep. And then switch 2 is bit 4. Now, so now I can actually use, well, bit 1 is this. Bit 1 is defined to be this 0x02. Okay, that's bit 1, right? When bit 1 is set, and that's the second position, the second bit, there's bit 0, bit 1's the next. So what I actually want to do here is I'll set up the selection registers. So now instead of using 0x02 everywhere, I could use switch 1. It just makes the code a little easier to understand when I'm looking at it. And actually, if I want to do both switch 1 and switch 2, I can just OR them together. So, and notice what this is doing. It's actually doing the AND equal, so it's reading that 8 bits, but it's only changing those 2 bits. Okay. Is that clear what that's doing? So switch 1 and switch 2, switch 1 is actually defined to be in binary 0, 0, 1, 0, and switch 2 is bit 4. So this would be hex. This is 16, decimal 16, or in hexadecimal, it's 0x10. This is 2, or in hexadecimal, it's also 2, 0x02. When we OR them together, well, you'll get what, 16 plus 2 or 18. I don't really care what that is. I'll just leave that always as an OR. But it's only going to affect these 2 bits that correspond to those switches. So now, note I'm taking, that's the binary inversion or not. So it's actually, the ORing of these is going to be 0, 0, 0, 1, 0, 0, 1, 0. This is bit 1, bit 4, or switch 1, switch 4. And then this is the ORing. And then this is then the NOT of that. So since I'm ANDing with this, everywhere I AND with 1, it's not going to change that bit in the register. But when I end with a 0, it's going to clear that bit. Remember, that's what I have to do with the selection bits. They both need to be set to 0 to put those in general purpose IO mode. So, but this, you wouldn't have to do it this way. We could do these individually, right? Switch 1 and then switch 2. This is just a little more convenient because now I can actually just cut and paste this. Oh, what I hit? Didn't hit Control B. So go back. Control C. Oh, there it finally took. And then for the direction register, want to clear it as well. For the pull-up, that's an O-ring, right? We want to set that, and we have to also set the out register. So that enables the internal pull-up resistors, okay, on both of these. And notice those are not, I'm not using the inversions because I'm setting those. So this is going to do the initialization of both switches for me. So how do I use this actually in my code? Well, the other thing I need to do is copy this over into the header file. This will be the prototype. Okay. And then that line needs to end with a semicolon. Now the other stuff there around the if not defined, that's called a header guard. That just makes sure that if this gets included twice, it really only gets included once. Okay, because what it's doing is the first time this gets included, it says, hey, if this is not defined, define it and then read the rest of this. Then if we include it again, it will say, oh, this is already defined because it was defined the previous time, so don't include this stuff a second time. So otherwise you'll get multiple definition errors if it accidentally gets included twice somehow. Now, typically in your LP switch file, we would include it here as well. All the prototype definitions. So this would be LP in single double quotes LP switch switch.h. Okay, so we've got to start. I've already got this one project that is using the switches. So let me test that this still works. So I can replace all of this stuff with the LP switch init. So a simple call there to replace all that initialization stuff. Now, there's a few other things I have to do here in this project. One is I have to include that header file, LP switch.h. And then the other thing I'll have to do is actually include that module in the project. And this is where you right click, we say add the files, and then these are, and this is in my EE354 source. I want the C and the H file, and I just want to link to them. Now linking to them means that they're not, it's not made a copy of it, so if I go back and make changes in the original file, those changes will automatically be reflected in here. If I made a copy of it, then it would just make a copy of the contents of the file at this point. And if I go back and change the originals, then the copies aren't going to be changed. So at this point, I've just got the one routine, but it's probably a good idea to go ahead and build this, see what kind of errors I get, because I almost never, and looks like there are several. Okay, so some, so let me click on, tells me here, oh, bit 1 is undefined. I included it here. Well, that's because it's actually defined in the MSP file, right? And I forgot to include that. So pound include msp.h, and then save that. Go back and try to recompile. And then now I got another error. It's saying that error is in and it's a stupid error on my part, but I misspelled LP switch, right? I got S capital W here, it was a typo, and it was actually supposed to be a lowercase w, so it's stuff like that that trips you up all the time, or trips me up all the time. And it's not easy figuring out what the error messages are. I'm down to one warning now. Okay, LP switch init, it says it's declared implicitly here, which means it wasn't declared in my H file. So I must have, it looks like I didn't save my H file. Here's the issue, notice the little asterisk there. And then since it's linked, it doesn't automatically save when I build a project. Okay. So let's try this one more time. I highly recommend that you fix all errors and warnings. We won't worry about the optimization stuff here now, but the warnings usually indicate that something is wrong. And then so now it's finally built. And so we could test it. The next thing we want to do though is, and I probably would test it, make sure it actually transfers over the board and works just like it did before. What this did is actually just read the switches. So let's go back into our switch routine, and then, here, switch 1, or we're going to call it read. And you might do this differently, pass it an argument so that it would actually read switch 1 or switch 2. That's kind of your choice. Here, we'll keep this really simple right now because we're almost out of time. So we won't have the debouncing code in here. But really, all that we need to do is that's port 1, and then it's the in register, and then if I AND that with switch 1, let me actually. If that's equal to 0, that means the switch is pressed. Now let me ask if this is what I want. So I'm testing to see if that switch, if that ANDing is 0, that means the switch is pressed. So if this ANDing is 0, if that's equal to 0, that means this will be 1. I'll return 1. So right now this is set up to return 1 if the switch is pressed, and it would return 0 if the switch is not pressed. Now you might want to define that differently, and I guess I don't really care, but you need to document it so that whoever uses it returns 0 if pressed. And return 1 if not pressed. Okay. So now, again, I need to put this in the header file, but the main thing is over here in my code now, I'm going to read where I've got this code, I'm going to replace that actually with, read with the LB switch 1 read. Okay. And I don't have to worry about what port it's on, what pin it's on. I've got a function now where all that stuff's implemented in the function. And so now I'll just use the read switch 1, read switch 2 routines in my code. Okay. Didn't get a chance to finish this, we're out of time. Any questions? Yes, no? Okay. 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 So it had so you had the wrong compiler.
She had the problem by the beginning.
Okay. So this is.
Does that make sense?
Okay. Good. Okay. Okay.
That's what I did.
Okay. You get some time to work on it. I gave you an extension until Monday.
So to handle the file, like what should I finish?
For the part 2.
I don't know, like for on the beginner, is it like I need to handle the first file and the second file? Like
Just turn out all that you have, and I'll open it back up and extend it.
so how can I carry it?
This is so include your source code and scan this and
I only have to include those.
oh, just the files. So just turn in really just this file is all that I want, all the files that make up your project. So you can copy and paste from here into some well, you can if you know where that file is, just upload that file or include it in an archive.
Okay.
Would be fine.
Okay. Thank you.
the board of like work, like, right, the first part, not the switch part, so is that okay, or?
No, you need to get the switch part working, so, but you've got until Monday to get it working.
Okay. Okay, I'll just try it.
大家等等吧。
是，如果实在不行的话，我一般把所有的有的包好就行。